Hello and welcome to this week's Maker Meeting from Workshop 88. Each week we explore projects that our members are working on. We are members of a community makerspace primarily serving the western Chicago suburbs. We're always striving to build and grow our community of makers. We believe that we become better makers by learning with and sharing with others. We hope you enjoy watching our meeting and we invite you to become involved with us no matter where you live. And before we get started, I want to remind you that we have our special running till the end of January for people living near us who would like to become Makerspace members. Please get in contact with us via the website and please check out our Patreon if you are not near us. But tonight we have a bunch of things that.
Hold on, Andrew. What was that deal?
The deal, yeah. So the deal is 4 months of membership for the cost of 3 months of membership. So $150 for 4 months of Workshop 88 membership, which we have access to the space fully if you are a member. We don't do public events right now, and we hope by the end of this year, maybe in the middle of this year, that we will. At work this week, I was in a group doing all these introductions and they wanted us to share what our goals were for the year. And my goal is to get jabbed in the arm twice. That's my goal. I'm setting my expectations really low. But anyway, yeah. So tonight we got some really cool things that I think we're going to talk about and share. And the first thing that we're going to hear about is a mapping project that was mentioned a little bit last week sometime. And I don't want to misrepresent it, so I'm just gonna turn it over to Mace, who's got something to share with us about mapping big data sets.
Hey everybody, we share the screen. I want to show you what got this all started in my mind. A couple of weeks ago, Phil Stranz made a presentation about collecting his weather balloons, and this was one of his slides. It was a three-dimensional map of the balloon's trajectory, its track, and projected in 3D. So these yellow lines here represent the altitude that balloon was off the ground. Now the ground looks flat here. There's probably some elevation changes, but the 3D map shows the path that balloon took. And that got me thinking of a buddy of mine. Can y'all see him? Oop. Yeah, let me try that again. This is John Link. He's been a buddy of mine since 1967. That's 7th grade in grammar school. And 2 years ago in 2018, he plotted out and rode a 4,500-mile bicycle trip around the eastern and midwestern states. The gear that you see him with there is all that he took with him. Something like 30 pounds worth of material. And he planned it for a year. He got everything going. And this, I guess I got to share this again. Hang on just a second. This was the route that he planned out and pretty much rode. He went from New York down the spine of the Appalachians to Atlanta, and then out across the mountains to the plains, to Springfield, up through Iowa, up into Eau Claire, Wisconsin, I think it was, to Chicago, where he met me and a couple of our friends, and then back to New York. Along the route, he took a GPS device with him. It was a program called Ride with GPS. And one of the things that it will do is track your GPS coordinates every 2 minutes or every 30 seconds, whatever it is. So he ended up at the end of his ride with something like 640,000 individual data points that mapped out his entire course throughout the loop. And I thought to myself, this map here is like a view from space. And I thought to myself, wouldn't it be great if we could take this map and kind of lay it flat and see the elevation as he rode from New York to Atlanta, obviously through the mountains would have been pretty tall, and then through the plains and out around, and see what that looks like in 3 dimensions. But I couldn't deal with 640,000 data points. I had to somehow whittle that down. And as a first pass, I just took the daily start and stop points. There were 73 of them, from New York to Middleton, Pennsylvania to whatever. And those were the only points that I dealt with. But that got pretty crude and raw, and you were missing a lot of the details of his ride. So I was looking around for some way to filter that data set down to something more manageable. And there's something called the Raymer Douglas Poiker, the link will be in the notes, algorithm that takes that large ordered list of data, in this case, mapping data, and only saves the points that are really important, that really make a difference into the shape of the curve. If I were to show you the map, I might say, well, he went from New York to Atlanta to Chicago and back. Well, that's just a simple triangle. And for a discussion like this, that might be good enough. 3 points is all I need for you to get an idea of what his route looked like. But that's a lot of detail you're missing. So the Raymer-Douglas-Poiker algorithm is designed to help save only the points that you really need. And what I want to do is quickly run through that. It won't be a lot of math at all, just primarily demonstration. So I'm going to try to run you through the algorithm. Can people see that?
I can see it.
Okay. Let's say that I drove from San Diego to Mackinac Island, and I took GPS coordinates along the way, 14 of them, I think it was, and this is what that looks like. So if we want to draw the route, the simplest thing to do, the first order approximation, as they call it, would simply be to draw a straight line from San Diego, the starting point, through the ending point, and that's it. That gives you a rough idea of where I rode, what the trip looked like. But you'll notice here that it completely missed the state of New Mexico, even though I had a couple of stops in there. So that's some detail that I'm throwing away. What the algorithm RDP does is once you have a first order approximation, you then, for all the points except your starting and ending, you draw the distance that that point is from your line. You don't want to draw it vertically like this. You want to draw it so that it intersects the line at a 90-degree angle. So this one's going to be really tiny. This one's going to be a little bit longer. And again, that's a 90-degree angle there. And this, I'm not being terribly accurate. All right. So I draw all those distances, and then I choose the point that is the largest distance. And that is, switch slides here. What it looks like. And those are the data points. And the next thing I do is to, I'm missing something. Where's all my data points? They were here once upon a time. Oh, well. You've got all these data points between the beginning and the end. One of the other things that you need to do is decide, well, how far off course are you willing to live with? And that's represented by this here, where I arbitrarily decided that any point lying outside of these blue dashed lines are too far off course. So this point here is outside that range, as is the next one over. The next couple are all in line, out of bounds, out of bounds, out of bounds, in bounds. The only things I really need to are the ones that look out of bounds. And that appear, the one that's furthest away appears to be this one right there. So I can't throw that point away. I have to save it. So by doing that, I redraw the graph and I end up with this now. This can be taken away. I really do need to find my original data set. Remember, there's points scattered all over, and now the route goes here to someplace in New Mexico and then up. And this splits the graph into two segments. This first segment down here and the second segment down here. The next step then is to run that same process for the two segments individually. It's a recursive call. Decide if there are any out of bound points in this segment and fix them, and then any out of bound segments over here and fix them. So if we take our boundary line and lay it down here, well, it looks like all the points in this segment here lie within the border, the error. So that segment is done. I now have to run the process on this segment here, and it looks like this is the point that's furthest away. It's the most out of bounds. So this point needs to get included. Now our line looks like this. And we keep going through that process until all of the points fit within whatever range we decided to specify. And in this particular example, I ended up in the end with 4 data points out of 14. I only needed 23% of the original points. Now, for John's ride, 640,000, 30% of the points is still 200,000. That's still way too many for me to deal with. So I'm going to have to either loosen up the error bounds or figure out something else to do to whittle it down even further. So the criteria that you use for this is either you're very strict on what those bounds have to be, and however many points you end up with is how many you get, or you play with the error until you get the number of points that you can deal with, something that your programs can handle. All right, so that's the algorithm. Let me go back to sharing. And I'll show you what those looked like. Here's one to start with. It's the 73 data points that I started with back in 2018. And I'm wondering whether I can get rid of any of these or not. Some of them lie along a pretty straight line. Other of them are kind of zigzaggy. And down along the bottom here, you can see this is the error that I'm willing to accept, 53. I don't remember if that's 53 miles or 53 degrees of latitude. But if I'm willing to accept that as the error, then I will end up keeping 2 out of the 73 points. So I reduced it by 97%. As I slide this slider here, notice the error value, it changes. I can set the error value with the slider, and all of a sudden at 8.7 miles or degrees of latitude or whatever, I end up with that triangle that I talked about earlier. You went from New York to Atlanta, up into Eau Claire, Wisconsin, which nobody knows where that is, back to New York. Well, you're right. We're all in Illinois. We probably do know where that all is. But there's still quite a few points that are just too far away from the route. So I'll just play with the error again. And at some point, as the error gets smaller and smaller, more and more of the points get included until I get to, I think it was, oh, maybe right around here, around 32 points, give or take. Seems to be a fairly close tracking graph. And I can deal with 32 points. It reduced the number of points in half. So that was pretty good, and I can deal with that. Next step then was to see what that looks like in 3D. Let's try this again. Screen share. Why am I not oh, there we go. That's the problem. Here's his map. I'm gone back to 73, all 73 points because I can. 73 is not too many. And what I can do, remember, this is the map viewed from the space station looking down. You can't really see where the altitude is. But if I rotate the map, you start to see the altitude data coming into play. And you can see down along the Blue Ridge Mountains, you get into some real altitude issues here. From Atlanta down across to the plains is pretty low in elevation. And then from there, back up pretty high in Eau Claire, Wisconsin. And it kind of shows where the altitude was. I can also rotate in this direction as well. So I'm actually walking around the outside of the route, looking at its elevation over the map. Now, that was very difficult to do. It took me a long time to program. It's actually pretty difficult to see. You can, unless you know what the map looks like, you can't tell if it's rotating front to back, back to front. It's all that optical illusion kind of stuff. But it was good enough. I sent this to my buddy. It was available the day after he finished his ride, and he got to see this, and then, you know, pats all around. Congratulations. So the next, then, after I saw Phil's graph, I said, well, yeah, that's kind of like what I was going after. So I asked Phil in a private conversation, what'd you use to do that? And he said it was Google Earth. So if we open that up, one of the things that I did was simply import a raw ride with GPS file. And that's this here. Google Earth does all this animation and zooms in. This is a hike that I took.
You're not sharing.
Oh, thank you, thank you, thank you. This is a hike I took outside of Newport Coast, California, where I was visiting relatives. Oh, this looks kind of cool. This is very much like what I was trying to get at originally. It's a hike through the mountains. You can see barely, depending on the angle. Let's see here. You can see some elevation changes. Again, it's an issue of the scale that was used in the elevation. Total, I think it was maybe 25 feet from start to end. Given the length of this whole thing, that's not a whole lot of incline. So it's a little difficult to see. Having the graph this high above the Earth, the raw ride with GPS file included altitude data. So if something was 300 meters, that was 300 meters above sea level. As it's graphed here, it's 300 meters above the surface of the Earth. So that's why this is so big, so tall compared to what was really happening. So I started to playing around. I took some raw data and I filtered it and sorted it and scaled it. And I ended up, well, for the time being, a very small data set. But you can clearly see, let's see, I hope you can clearly see. I think I doubled the scale. And I think it's a lot easier to see that starting out at whatever elevation this is, slight downward turn and then some uphill moving around. And I can, like I intended to do all along, rotate this in 3D space to see where I walked and what that inclination was. So I still have to take that entire data set, run it through the RDP algorithm, get down to a manageable number of points. But once I get that, I know how to pop it into Google Earth, play with the scale so that you can see elevation changes more easily, and hopefully show you his entire route in 3D. And that's what I got for you.
Very cool. Thank you.
That's great. I loved your description or illustration or demonstration of the Douglas Poiker algorithm. That was fantastic. Are you doing all of this in lat long?
Yes.
Okay. And what app were you using that was showing iPhone 8, iPhone 7? Like
Xcode, the developer. I'm a
Xcode.
programmer, so I was just writing in the Xcode programmer's environment, and then running it in a simulator. And I had two of them running.
How did you generate the KML? Is that what your program output?
The original Ride with GPS program exports TPX, and that can be imported into Google Earth. But Phil also let me know that there was a Python library that can output KML files, and that is what I used for that final short realistic altitude hike that I had taken. I wrote out my own KML file using the data that came from Ride with GPS and filtered and sorted and trimmed and set it in and all the rest of that.
Cool. And have you played with elevation color?
No.
Coloring by elevation? That's sometimes helpful in visualization.
That would be cool too.
All right, that's the end of my interrogation. Thank you so much.
So I love that.
Thank you, Phil, by the way.
Yeah.
Oh, sure. Yeah.
I really love the demo that you did as well. And my question, I guess, is, well, I just love the application of the algorithm too. So that's really cool. But part of my ignorance, I guess, is, presumably if the GPS is making measurements over or every minute or every 2 minutes or whatever it is, you really aren't, you really don't care about all the points that are when it's a straight shot, those sorts of things, which I understand, like inherently the algorithm would take care of. I mean, it seems clear from your demo that that's true. But it would also kind of seem to me, and again, this is my naive way of thinking, what if before applying the algorithm, you just like did some sort of like truncation of just like, I don't know, every like only accept every 5 data points or something like that. You know what I mean?
Every 5th data point?
Yeah, every 5th data.
I wouldn't do it. If you're on a hill doing switchbacks back and forth, you might want to keep that data. But every 5th point, first one might be at the bottom of the hill, 5th one at the top of the hill, and you miss all that interesting little climb. So you can't do it arbitrarily.
Okay, got it. No, that totally makes sense. I can totally see that.
Now with 640,000 data points, running the algorithm, changing that epsilon ever so slightly so you can see how many points you're in, takes forever. That's a lot of data points. I think it's big O end of the 3 for this algorithm. So there might be some kind of filtering that you can do to make a much faster pass looking for straight lines or something like that. Maybe a change in direction. If the direction hasn't changed by more than whatever, you can run through that data set once and throw out everything that didn't deviate by 2 degrees or 1 degree or whatever else. And then give the rest to the RDP algorithm to save, again, just the important corners, basically, of the route.
Yeah, but doesn't that lose you, interesting straight line altitude changes?
No, because the altitude change could be up and down and up and down and up and down and up and down and up and down. But if they're all on a straight line, the RDP algorithm would have thrown them out anyway, because they're all on the same road within 5-10 feet or whatever it is. Yeah, you're not capturing all of the altitude changes. You're only capturing X and Y deviations, which is a good point. RDP is only a 2-dimensional algorithm. If you wanted to do 3D filtering,
yeah, cool.
That's a whole other.
Hold on. RDP can be used in n dimensions, and it just depends on how you define the error corridor. And it's because RDP is actually used in GPSs and navigation systems. I work for a company that makes maps, and we use it all the time. And there's another flavor where you were doing the recursive method that gets you the actual right perfect answer. There's another faster flavor where you just go from one end, and every time you test a point, just like he described and showed, and if it's within your error bands in the direction you're going, you can just keep the last point, discard everything in the middle, and then once you get one that's out of bounds, you add a new vertex, and then you're just kind of moving forward. But you can, however you define your error, you're just making a decision whether to keep or discard points.
I guess you're right. I always thought, I could never understand why RDP, why I read that it couldn't be used in 3 dimensions. I'm just thinking, why don't, instead of a band of error, it would be a cylinder, and anything outside that cylinder would take care of elevation. But I can't remember where I read it, but somebody said, no, it's not. This algorithm isn't appropriate, or maybe the way I'm doing it, whatever, I don't know.
It's still perfect. It's perfect for what you're doing. I mean, yeah.
And fast enough. I mean, once I get through that first data set, I don't have to do it interactively. I can just send it through a program and 5 minutes later get my data points. So that works out fine.
Very cool. Well, thank you so much for sharing that. And I look forward to seeing what I assume will eventually be a 3D printed topological map of this path or whatever. That would be pretty cool. So yeah, we'll look forward to tracking that.
I wanted to actually do a 3D flyby. I wanted to ride his route in 3 dimensions with Google Earth, and I don't know that I could do it. I would, though, like to play, if I may, one last bit of code here. I think, yeah. I'll fast forward to some good points. This is one of John's ride legs. It starts in Zion, Illinois Beach State Park, and goes to Hyde Park. First 20 seconds are just a goof. And there he is, that's a starting point. And then the Google Earth does a fly through. So you could see exactly what route he took. I don't know what Google's simplification mechanism is, but at 8:04, there was some interesting scenery. Let's come over here. It's coming up to the Baha'i Temple in Evanston. John and I were roommates at one time. We lived in Evanston, right by the Baha'i. And I think this flyby is just so cool. It's not looking at the temple, but clearly you can see what's going on there. And this is Linden Avenue. And this right here is the end of the line for the CTA in Wilmette. And coming up here, that's the apartment that John and I lived for a couple of years. He was doing his PhD in econometrics at Northwestern, and I was working full-time for the Quaker Oats Company. Short walk to the Linden stop, and then hop on the Evanston Express. First Chicago stop was Merchandise Mart, and that was mine. So there was that. And then finally at 11:20, John finally gets to Lakeshore Drive and the park. And all of a sudden, Google decides now it's important to see some scenery. And it shows the trees and all the buildings in 3 dimensions and flies through the route that he actually rode. This little blue line that you see along the bottom, that is the actual route that he tracked with a GPS unit up to Diversity Harbor, Belmont Harbor, and around through everything. It's just beautiful. I wanted to do this for his entire route. This one leg took him 7 hours plus. This fly through is in 15 minutes. And I showed it to him the other day and he says, you know, it looks way different from the air than it does from the ground as you're actually riding it. So I can certainly believe that's true.
It'd be kind of interesting to add a few more dimensions of data. You know, say for example, heart rate and velocity. I don't know how you could do that though.
Well, velocity is implied by the time between the data points, so you could generate that, as well as change in elevation. And there's, you know, you can have a whole dashboard of this, and then throw it on a Raspberry Pi or something and actually put it on your bike as you're riding and see it and all there. That'd be cool.
Yeah. But I suppose you could do that, you know, velocity could be a color too, maybe.
Speaking of Raspberry Pi, another cool plotting tool for this kind of stuff is Mathematica, which you can get for free on the Raspberry Pi operating system. I did that at one point. I was collecting GPS data from a bike ride and was able to plot it in 3D and then also have a color map that corresponded to the speed. It's pretty cool.
Someday we're going to have a discussion about Mathematica. I sometimes use Mathematica, and I've been meaning to poke some people on, you know, at Workshop 88 for opinions on making graphs that Mathematica outputs, making them prettier. And
I've actually been migrating Mathematica to Python. It's I don't know.
Yeah, I've done similar, although I'm kind of fluctuating back a little bit, but whatever.
Yeah.
Cool. Well, we can have a discussion about making pretty graphs in Python too. That's also, I'm also up for that. All right, thanks, Mace. That was awesome. We'll look forward to more updates as that project progresses. Next up, I think, is Jim, who also wants to talk about topology of some sort, right? Is that the plan? Jim, tell us what you got.
I can find the unmute button. Yeah, well, it's much more physical topology. This is a sort of a discussion question, and it's weird. So let's see if I can push the right buttons here. So I had this is a recurring problem. I make stuff. You know, I've been bending metal for, you know, a long time, let's say, and fine. Most of the time it's all cool, but there's times that I can't do what I want to do. If I were working with some thin aluminum or something, yeah, I could grab it with the needle nose pliers and bend around that. This was a bracket for something. It's a microphone boom, doesn't matter. And it was just a tight fit over that shelf. And I really didn't care about the top part. I had to attach, it's like a piece of number 12 copper wire. I didn't care what that was, but the bottom part was critical. The thickness, it had to push on just right. And that's fine. And I got the first couple of bends, and then I couldn't figure out how to bend the rest. And probably it was that this last bend, if I had to guess. I don't remember exactly, what it was. And I couldn't bend it. And I'm just sticking this thing in a vise, right, and hitting it with a hammer. And I've bent a lot of metal, and sometimes you can't get there. And the question or the topic is, I want to be better at this the next time I've got to do some weird bending job. And part of that, I think, is tools. It keeps feeling like, man, if I just had this super duper needle nose pliers that could make some, it's usually a tight bend that's the problem. But a needle nose isn't going to do it when you got some steel that's got any kind of thickness at all. So the question is, what tools do I need that I don't have, or what techniques? And the techniques is certainly part of it, and that's a harder question. This is teach me to be creative with tools. So let's see. So I've been bending stuff for a long time, and I'm happy to steal other people's techniques, and and it usually the problems involve making tight bends about something. So yeah, fine, I can do this. I don't know, it's like number 10 wire or something. And I've been doing this for a long time, and I can bend stuff, and I can abuse my vise, and use some little corner of something so that I can get a force just on the right direction and the right part of something to tighten something up or loosen something or whatever I'm trying to do. And I can even use tools. So here, making a right angle bend, fine. I could just take that piece of strap and put it in the vise and hammer on it and get a nice 90. But if I'm trying to make something narrow, and this is sort of like the one in that bracket I showed in the first place, but there's nothing magic. I had a piece of 1/4-inch steel bar. And yeah, there's clever things you can do about, clamping something in a vise and clamping it between that and another piece of something that happens to be shaped the right way. And, then maybe you can beat on it or squeeze it with a vise or whatever you're trying to do to get what you're trying to bend. And it's, so now it's getting to be hard. This is clever. This is exactly a clever way to bend something. And you can't do this in the vise because you can't, something gets in the way. But if you use a tool, if you take a chunk of stuff, you can maybe bend something around it. So the question is, what do I need? How do I get better at this? And I can think about, stuff like this, about using a chunk of bar stock, and that's sometimes useful. As I looked around, there is a sheet metal bending tool, duckbill pliers. This looks pretty interesting. I don't have one of these yet. The metal in the jaws isn't as thick maybe as I'd like, but this sort of approaches this mythical, very, very strong needle nose pliers. It's obviously not needle nose, but often I'm trying to bend, a bracket or something. And this is, I didn't even know about these. This is a vise mounted press brake. And, so it's just, I don't know, magnets or something, clip it on your vise, and you put a piece of sheet in here. This is the little, bender thing, and this is the receiver. and it'll bend, 90 degrees and stuff. This one is a fingered one, so that there's, I don't know what you can see. This is one piece of metal. From here to here is another piece of metal, and another, I think they're like two 2-inchers and a 1-incher or something. So you can loosen the screws and take these things out, and you can maybe build a box by cleverly locating these. And the cleverly is part of it. You can't teach me how to be clever with my tools, but that's part of what I'm asking, I guess. So the question is, how do I address this? Are there other tools? And this one is a press brake. Well, most of the time I can just put a piece of metal in the vise and hammer on it and do that. This felt like it might be useful because it's got some other shapes that I could maybe use sometime to bend something a way that this tool wasn't designed to use. Way it wasn't designed to be used. So anyway, sort of the question is anybody got one of these things? Are they cool? Have you been glad you had them? Have you tried to, bend heavier brackety stuff, with something like this? There's thinner ones that are okay for thin sheet metal ductwork or something, and they're not good enough to beat on. This, I could have put that bracket in here and hammered on it somehow, I think, probably. But I don't know, I've never used one of these. So all you makers out there and all you benders, and maybe this should be in the bender channel, but are these cool? Do you love these? Man, I couldn't bend half the stuff I got to bend without this. Or are there other, the other tools that I don't know? Or I don't know. Oh yeah, you always start from the middle and work your way out, but I don't think that's a true technique. I don't think that always works. And how to be creative about what you clamp, and put an extra spacer in here. And I want to learn those things. Watch a lot of YouTube videos and watch, the sharp guys' hands and see what they do and learn from that. Anyway, that's kind of the question.
How much is that press brake?
$50, 60.
How wide is it? For 5 inches?
That's 4-inch. Another $20 and you get a 6-inch.
Yeah, you'll find that those will make better, straighter creases that don't have a bunch of hammer marks all over the outside.
How do you know I got hammer marks all? Yeah,
because I know I work the same way. The other thing is I've been known to use a screwdriver as a mandrel. You have many hardened steel cylinders in your toolbox. I have multiple sets of screwdrivers, and you've got the right idea. I mean, I'm with you in terms of using scrap steel. I usually have more angle iron around than I have like L so I'm always clamping something into the vise. But and when I hammer, I'll try and use a heavy hammer, and I try not to hammer the metal directly. I try and put something between the hammer and the metal. Not something as big as a 1, 2, 3 block. You shouldn't be beating on your 1, 2, 3 blocks anyway. But your 1/4-inch piece of steel there between it and the metal, you're going to spread that force out and get more of a roller. That's my 2 cents. So I do like to use the vise a lot to bend metal rather than hit it. Rather than striking it, I like to try and form it.
Right.
Yeah. Order of operations will kill you half the time. And I've done steps 1 through 5. Now, how do I hold it?
Yeah. Yep, that's the one.
So your vise tool there, I've seen over the past couple of years, I've seen from time to time, like on Hackaday, I think I saw this where someone 3D printed the tools to do bending in a vise, and the 3D material, 3D printed material actually holds up pretty well through multiple bends.
Yeah, I'd seen some 3D printed suggestions about that, and it struck me that a piece of hardened steel might do better. But I haven't done that.
Yeah, hardened steel is harder to print.
A while back, I was working on trying to make some recirculating bearings, and I needed to bend some tube, and I had actually 3D printed a bending fixture, and it actually worked pretty good for it was like brake line tubing. You know, something to think about. The only thing I can think about on that vise is you got that you don't have a lot of clearance, so you know you can't really you might be limited on depending on what you're bending on some capacity there. I could see something like that if you had like an adapter for like a arbor press or something like that. That would
Right.
be, you know, an arbor press, you know, maybe for an arbor press, or, you know, on the other hand, we got that combo mill at workshop, or not combo mill, that
The
hardware
push brake
Those are
shear?
shear brake rolling
shear brake
mill,
combo.
yeah.
Yeah.
Yeah, that's cool, and you had mentioned some other bending stuff there.
Yeah.
Those are cool. It's the one that I want to do at midnight without making a run to the space. You know, so I'm trying to see, you know,
I was
justification
trying to
for
promote
buying new
memberships
tools
in
is
a
cool.
space, you know.
I understand your point, Jim, but didn't you guys, I wasn't there for it, I saw it on Slack. Didn't you guys make a nice enclosure for the CNC mill with using the press brake?
Yeah.
Yeah.
Well, well, not an enclosure. Well, it's actually, well, yeah. Well, not enclosure, not for the power supply. Yeah. That was kind of fun. Yeah, we did that a while back for that, you know. Yeah. So, yeah, I mean, that, you know, basic press brake operations are pretty cool, you know, except, you know, on that shear brake combo, you don't have a back gauge or anything like that. So that's the only downside. You kind of have to figure out where your bend line is. So a little more complicated there.
Right.
So look at this. You can get these bending tools for $10. The shipping's 1,600.
I'm not seeing actual pictures. I'm just seeing
Yeah,
a
we're seeing a black
Scott has
screen there,
started.
Scott.
No way.
Yeah.
Wait, watch this. Is it now? Do you see anything?
No.
Oh, yep.
Now we do.
Yep, there it is.
Sorry, guys. It depends on the monitor I use. Now do you see it?
Yeah.
The $1,600 shipping for the $10 press brake tool.
Cool.
Oh well, buy everywhere.
What if you buy two? Is
I'm
the,
gonna buy 500 and resell them.
is the shipping discounted?
Yeah, I don't know.
Wow.
Yeah, part is tools and part is, you know, like Scott's suggestion of, you know, here, well, you know, use screwdrivers is nice round mandrels. But I don't know how I would teach, you know, somebody I was working with how to be creative with tools. But that's what I want somebody to teach me.
What I heard was you should use Scott's screwdrivers. That's what I heard. Be creative with his tools.
Ah, okay. Well, actually, I've already I can't grab it from here. There's some nice soft vice jaws made out of masonite and duct tape that were a clone of, you know, stuff that Scott showed. So yeah, I'm with that.
Well, there's also I mean, the bracket you showed earlier is pretty simple, but you know, there's some CAD tools that can be helpful. Even I don't well, I haven't looked at Fusion 360 in a while since they changed their licensing model, but they do have a tool for sheet metal bending, and
Actually, FreeCAD
FreeCAD?
has a workbench for 3D bending.
with all due respect to software, it doesn't bend the metal, and that's really the question.
Well, sometimes a good plan before you start is the idea.
Planning is good, yes.
You're just not using the right software. Very cool. Well,
Anyway, so that was the questions, and thank you for your comments and suggestions. And if I in fact get that press break, which I probably will, yeah, I'll maybe show it off and say, oh, here, this is why this is a great thing, and this is why it sucks, and you know, all that stuff.
It'd be nice if you shared that link with our viewers and me. Also, I'd like to know in that bracket that you made, could you show the picture again and just tell us the order of bends that you did? It sounds like you worked from bottom to top, but I wasn't sure.
Hard to say. If I had to get, am I sharing?
Yeah.
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 Hard to guess, and this is part of it too. Maybe what you should do.
Double click on that image, Jim.
Is that? Can you see it or?
You may be sharing the wrong window. We see the thumbnails.
I see the whole thing.
Okay, everyone, let's go to Jim's house.
You see that?
Nope.
No,
Just
still
thumbnails.
thumbnail.
Okay. Can you see it now?
Yes.
So one of the arguments, and this is the kind of crap that I'm expecting people to throw at me, is, well, Jim, you should plan this thing out in the first place, and maybe this is going to be the hard part to bend, and so do the hard part first. While you've still got this other stuff is nice and straight, and you can work easily. And so the order of operations is an interesting question. But after I've bent this, I could probably bend that around a piece of 1/4-inch bar. Well, now this damn thing is in the way, and I can't chuck this in the vise to make the other bends. Well, yeah, actually, I could put a spacer in here and then clamp in the vise between this surface and this surface with the spacer in there, and then I could, bend this around, the corner of the vise jaw. Although this one's going to be hard. The problem was that this spacing is critical. And so my whole concentration is, I don't care about order of operations. I got to get this has to be right, or the whole thing doesn't work. It's got to be springy, and it's a little curvy here so it doesn't scratch up. And this is the critical part. I don't really care what's up here. I'll figure out some way to attach to it. And then the order of operations. Then I'd gotten this stuff done, and well, now what am I going to do? And now I can't bend this tight like I want. I'm sorry?
You might want to Google like bend deduction and bend allowance in sheet metal, because the metal is actually stretched. The length of the metal is changing when you're bending it because it's stretching.
Oh, sure. But the problem is not making accurate measurements. The problem is just actually doing the bend, having some tool strong enough that I can hold this part while I bend this part, whether it's being formed by screw threads or hammered on, or whatever the mechanism.
There is something else that's all the rage these days. I see them on lots of videos, and that's inductive heaters.
Yeah, well, or a torch. I mean,
yeah, you just need a bigger hammer, Jim.
Well, that was Scott's thing, I thought.
Yeah.
Yeah. I wonder if I seriously, I think do you own an arbor press or anything like that?
No, and an arbor press is another, I've kind of lusted after those too. For just this kind of thing, it's one more forceful tool to bend stuff or break stuff or smush stuff or whatever I got to do.
Yeah, I have one in the basement that years ago when Enco was still around, I went there and they had like a factory return. It was like missing pieces on it, so I bought it at a discount. I never have finished it, You know, I got this half finished arbor press in my basement that, you know, just waiting to, you know, probably 20, 30 years I've had it. It just never got around to totally fixing it. So
Yep.
one of these days. Yeah.
Anyway, well, thanks, guys. There's lots of other stuff to talk about. I don't want to hog the whole time.
Keep bringing it back to Slack, man. And this is what I love about the community. And by the way, I'm going to double back to Mace and say that if you have any more ideas, you know, your project looked pretty well done, but if you had more ideas about how to visualize stuff or, you know, how to discuss the software approach, you know, bring it up in software. I love this stuff.
Very cool. All right, so I have a really quick hit to share, and I guess this actually goes back. Sometimes I remember when I was very first becoming a member of Workshop 88, the one of the founders of the Makerspace, he liked to ask people just, well, what do you like to make, or what do you want to make, or whatever, and which I think we still ask people that when we're getting to know them. And I very much distinctly remember saying like, well, I really would like to get into making toys, basically is what it is. And not that like I didn't have a son at the time, but you know, toys for myself, toys for kids, whatever, just toys in general. And so one of the things that I had stashed away about that time, maybe a little bit before joining Workshop 88, was this PDF that I found, which I think is still available somewhere online. It's called Puzzle Craft, and it's a book of just basically puzzle designs. This guy Stuart Coffin has like hundreds of puzzle designs, and there's a couple other books that were published, and so I think I shared this a while back, but I made this I took this design and I learned about rotating things and we had a discussion about the rotation and how the dimensions can change upon rotation in CAD programs, which was a surprise to me. So that was fun. But I wanted to laser cut that, but I didn't really actually get to ever laser cut that yet. And so the design that I landed on was a more three-dimensional design, and it's this, whoops, I don't know why that did that. It's this half-hour puzzle, which is 6 pieces, and the 6 pieces are made up of cubes of same size or whatever. And so I jumped over into Tinkercad, although I did think about doing this in OpenSCAD, but I thought, well, I'm just going to go to Tinkercad because I was working in that for something else. And I very quickly came up with the 6 pieces and kind of put them all together, and then exported them as an STL and printed it. And I have it here next to me. But before I show that, I will just share that I posted this on the Workshop 88 Twitter page, and I said that this puzzle was based on a design originally called the half-hour puzzle. I've been trying to solve it for 2 hours with no luck. And then someone who I happen to know via professional reasons said, "Oh, these are called Soma cubes," which was not in the thing that I had. And I was like, "Oh, okay, that's cool. I'd never heard of that." And eventually, I did get it solved. So it is here in a cube form. But two really quick things about that. One of the things that I really liked about this was that there's 27 unit blocks in the shape, and so that's how you get a 3 by 3 by 3 cube. But then there's like other possible arrangements that these particular shapes can be arranged into. And I have not tried all of these, but I kind of think this is kind of a fun little, I mean, these are all interesting variations on the puzzle, and I would like to try coming up with these, because apparently these are all possible with the pieces that are here. But then I learned that if you go to Thingiverse and you search for, I searched for Soma Cube, and there are a whole bunch of Soma Cube models on here. And so I said, okay, well, maybe this is a popular thing. And yes, it's actually very popular. Soma Cubes they're made they're made out of knitting, they're made out of wood, made out of lots of things, 3D printed, whatever. And so then I got to learn a little bit about the history of Soma, because I thought, well, man, this guy didn't like call them Soma at all, and he talked about this or whatever. And so then I was looking at this, and there's kind of an interesting story about the origin of the Soma Cube. Apparently, it's credited by a Danish person, Piet Hein, who was spacing off during a lecture by Heisenberg of the uncertainty principle. And there's some question as to whether or not it was 1936 when this was done, or if it was 1933 or whatever.
It was uncertain.
That's good. That's good. Like that. They know exactly where it happened. They know exactly where it happened. They just don't know when, right? Yeah. And so there's some interesting bits to that or whatever. And I guess there's a patent or something. But then I came down to this, and I was like, wait a minute, because here's the Danish patent, and there's not 6 pieces, there's actually 7. And so even though this makes the 3 by 3 by 3 cube, these shapes are not the same as these shapes, because there's only 6 cubes here, or six pieces, I mean, to make up the 3 by 3 by 3 cube, whereas the traditional Soma cube puzzle has 7 pieces. So I was like, oh, okay, so it is different, and these possible designs are slightly different or whatever. So anyway, that's I don't have much more to add to that, other than I had not heard of Soma cubes. For a while I thought that this was the Soma cube, but it is not. And I'm still very interested in doing the working through this book of other designs. I started with this because I thought it was super easy to make with a 3D printer, and then just try to, maybe go to the next ones are going to be more challenging things, not necessarily more challenging to print, but more challenging to solve, and so on and so forth. One of the things that I'm a little, I don't know what to do with this sort of stuff other than make it for myself, because it's a question of design and copyright and intellectual property and that sort of thing. And I'm not 100% convinced that all of these designs that are in this book are 100% original ideas of this one guy. On the other hand, maybe a lot of them are, but also like I don't know. I just don't know where the IP starts and stops and that sort of thing. Like
apparently no one cares on Etsy.
Well, yeah, that is a thing. I mean, like the Danish Soma cubes. Well, yeah, I don't know how a Danish patent translates to American intellectual property law or whatever.
And stuff.
But anyway,
What would you like to do, Andrew?
well, I would like to publish the designs. That's one thing, basically, because like one of the things that I think is really lacking with this book, I mean, the this PDF is out there, and from what I can tell, the author, wants he wants the designs out there, basically. Like, he wants the PDF, he wants the book out there. He's not trying to like sell the book or anything like that. But I don't think a lot of people know about it. And so I think there are a lot of good things in here that should be available for people to try to make and play around with, right? I'd love to be able to make my own designs, but that's not something I'm really like going for right now. So anyway, that's it was fun. It was a fun first thing to do, and I'm hoping to do some of the more interesting and more intricate puzzles down the road. Like these burr puzzles, I think are super fascinating because they're way more intricate in their design and how they interlock together.
Yeah, they're like Japanese joinery.
Yeah.
My dad had a blue Soma cube. I wanted to ask, did anyone else have a Soma cube or have access to one when they were a kid? Okay, that was a short conversation. Thanks.
I didn't think that this would be a super long, discussion or whatever, but
I have a wooden version of one of these. I don't know if it's technically a Soma cube, but it's kind of like what you were showing, Andrew. And then the thing that always seemed to happen over the years would be that either my sister's kids or my sister-in-law's kids would find it and pick it up and take it apart, and then I would have to put it back together.
Andrew, real quick
Did it
question.
take you half an hour?
Go into this? Oh, have I shown you this before? Oh, it's not looking too good. This puzzle. All right. When Earth returns to normal, I'm going to share this with you.
Okay, cool. Tom, what'd you say?
I forgot.
Oh, okay.
Yeah, actually, I was kind of looking at the link that Jim had posted in the conversation, and I was thinking you could, I don't know, $85, and I was thinking, well, that's just a little steel. You could, cut the V, and we got that furnace there. We could heat treat the steel. And
Well, there are lots of YouTube videos about how to make your own, various versions of this.
Yeah. I mean, just looking at it, it just seems to me that the limitation is going to be for the devices. Well, if you could maybe rotate it to where you're bending opposite, so you're not going to hit the throat. I think that's what the limitation on that's going to be. If it could be turned 90 degrees somehow, I think that would work a lot better.
Huh, interesting. Thank you.
Yeah. So my 2 cents.
All right. So I think now it's a good time for any other discussion that we want to have. The one topic we had possibly talking about was what we have in our stash wherever we do our work that we consider to be a staple and something that is either and I was thinking about this earlier, like either something that's obviously a staple and needs to be always on hand so that you can have it, or something that's not obviously a staple. And I can give you a couple examples of things that I think are obviously a staple and not obviously a staple. So for example, where I have my 3D printers here at home, the PLA, the filament is a staple, right? You cannot do the 3D printing without the filament. And so that's the thing that's obvious. What's become a little maybe less obvious, but I'm starting to maybe rethink my strategy is like a lot of the members, not everyone, maybe I'm the only one on this call right now, but a lot of us at Workshop 88 have the Ender 3 Pro 3D printer, and it has the flexible mat. And I've shown previously how I had a problem with it where the head went into the mat and sort of scratched it all up, and I had to get a new one or whatever. And I put probably, I don't know, close to 300 or 400 hours on the next mat that I've got, and I'm starting to think that mat is, the second one, is wearing out, not because it's been abused, but because it's been used, and that I probably should have thought about a backup one. And I know some people print on glass, and so maybe you have glass beds ready to go and like in the backup or whatever. And so that's something that's sort of a less obvious staple that you might think about keeping on hand. The one idea that really came to my mind in terms of made me think of this as a conversation was I really like having heavy duty contractor bags on hand, so that when I go to clean up something that's really heavy and a mess, I need to do that. Oh, look, Christine has her stash of beds. Nice. Oh, so I guess what you're saying is when I need one and I haven't ordered it, I should just hit up Christine, basically. All right, that's cool. But the heavy duty contractor bags is something that I wanted it and it was gone because I forgot to replace it when I used the last one. So
Yeah, these are all Prusa i3 spring steel.
okay.
So yeah, burned through a couple.
And I like having those big contractor bags around, not even just for bags all the time. Sometimes I split them open and, it's a nice big plastic sheet. If you're using a vacuum table or if you need to cover a fountain or, if you need to fashion a parachute and you don't have one for your weather balloon.
Duct tape. Come on, duct
Radio
tape.
sound?
Radio sun.
You got to have duct tape on hand. That
So
goes without saying.
I have a new tool addition, and I have an old and a new, and they're both silicone tubing. And when I say silicone tubing, I used to be really into radio control and nitro gas stuff. By the way, I got a whole bunch of gallons partially full of 10, 15, and 30% nitromethane for RC cars, or the nitro fuel. I have to get rid of it. I don't know if it's good anymore. It might be, but might not be. If anyone has a use for it, let me know. But so I've got a bunch of fuel line from various diameters and stuff. And I saw a hack to put one on the end of your solder sucker. And if you know about using a solder sucker, you would use it. If you don't know, you would you might have a circuit board you want to remove a part, or you want to redress it. My camera's not focusing very well. There we go. And you would use a solder sucker. You'd heat it up with the iron, and then you put the solder sucker on it, and you press this button, and a spring-loaded plunger goes boop, and it creates suction. By putting a little piece, and it doesn't take much at all, of fuel line on the end, I can get into that circuit. And silicone is very tolerant to heat. It won't melt, it won't burn. And I can get it in there and really just smush it on there. And wow, does it change the performance? And it makes the whole job easier. You're not trying to angle it with the iron and stuff. And all of my tips in the old days would get worn down because they would melt over time. And one more thing I want to show with this is if I just hold my finger over the end of it and press the button, I mean, that's how good the seal is. Like, so if you ever use a solder sucker, that's it. The other tip is to put the silicone tubing over the tips of pliers. If you're ever using pliers and you don't want to mar the surface, the silicone tubing is you can get a really good grip and still not mark up a surface. It's a smaller tip.
I wonder if aquarium pump tubing would be different than fuel line tubing.
Silicone tubing, surgical tubing, or RC car tubing. I don't know if aquarium pump is silicone or if it's
I think it's usually vinyl.
That would not be ideal in my opinion, but I haven't tried it.
Similar to your last point there, Scott, I put the alligator clips on helping hands, I'll put a little bit of heat shrink tubing on there and then heat it up. And so then the alligator clips, when I clip onto a circuit board or whatever, it doesn't scratch things up.
I like that idea. I might have to rip that one off.
Once again, when we're allowed to go back outside and when we can meet each other, I have enough old tubing that I'm probably not going to use anytime soon. And if any of my closest friends would like to dress up their solder suckers, I think I could spare a few inches. And in the meantime, hit me up on Slack and let me know. I could leave pieces for anyone at the space.
There's going to be a trail of silicone tubing leading from Wheaton to Glen Ellyn to Naperville. Just like we'll know exactly where Scott has been. No need for a GPS tracking device.
If only we had a drone that could deliver that to our house.
My license won't let me fly out of sight. Speaking of that, real quick, if I remember correctly, Jamie, were you the one who had the drone project with the archaeological stuff, or am I getting you confused with someone else?
Nope, that's me.
Well, if you ever want to talk about that on Slack or elsewhere, hit me up. I don't know if I volunteered before last time when we spoke. Good to see you again.
Yeah, good to see you too. Yeah, I just got to get all that stuff moving again. Everything is slowly starting to turn those wheels now. So it's
I just wanted to say I'm interested and willing to help.
Oh yeah, no, that'll be great. Actually, part of it is I've been thinking about going for my own drone pilot license and just kind of started studying for it and then totally fell off and it kind of just fell by the wayside, but I should get back into it.
You talking about an actual 107?
Yeah. Yeah, it's my professor has I don't know, it's like a degree or whatever degrees higher that the federal government gives their agents. But he has highly recommended us students getting Part 107s if we're interested in flying professionally. So
For those of us who are not in the know, in 20 words or less, what is a 107 license?
the professional drone operating pilot license basically allows the government allowing you to commercially fly drones.
Okay. So that could be potentially out of line of sight, that type of thing.
No.
No, that's still not allowed.
Oh. Okay.
And for the most part, as far as I understand, it's not over people or anything particularly fun either.
So those rules are changing. There was a proposed FAA ruling that they're currently going through that does change a lot of those rules and makes them more codified. So it's coming.
Anyone else wondering what Tom's got going on in the back of his head, like that he's a little obsessed with dangerous things flying over people's heads that nobody's paying attention to?
He just wants me to drop off the tubing.
Stuff flying over my head. That's just my mic. There you go. There, happy?
You got it.
Okay.
All right. Very cool. Yeah. Is there what other topics or questions or?
We want to talk about the riser block?
Well, I was going to call you out, Tom, and ask where the rotary attachment is for the laser cutter. How's that coming?
Well, I mean, we were talking about that the other day because, I mean, on the full spectrum laser, if we were going to getting any kind of meaningful block in there, we have to raise the whole laser up, I think.
What if we put the laser on treads that were driven by a stepper motor from the y-axis, and then it could just crawl all the way across the material?
Can we do it while no
We,
one's
we almost had him.
Well,
I am not opposed. I'm just joking around. We can make the riser first. There's it.
well, I mean, we can make both. I work on both, I guess, and then sooner or later, it's just I don't think we could get any kind of meaningful diameter in there because of the constraints. I don't think.
I think you could pick up a little bit by getting a shorter focal length lens, but only a little bit.
Yeah. But I saw your, and I saw on Slack, Jim, you had your post, and originally, I was thinking, we were talking about having an ability to slide longer pieces in there. So I'm assuming to do, cut and then do a shift and do another cut that or burn, if we want to call it that, cut or burn. But so then would we have like a riser block with a slot in there that we could basically feed longer material through it?
But once you're into taking the bottom off the laser, whether you're going to have a riser block or feet or something so that you could have a arbitrary length, y-axis, it's just kind of all part of the same thing. Just something to think about if we're going to, start rebuilding the bottom end of the laser. What should we do? Just various possibilities.
Well, then too, if we, I was, I had seen it always, it never occurred to me on your sketch that you made. You had the feeding the material in on the width side that would allow you a very wide piece of material. And for some reason, I had always visualized it feeding it through the short end.
Why would you feed material? We could just set the laser on top of whatever you want to. You could feed it either way, or you could do a tiled based pattern. I think it's more versatile if you could feed it either way. If there's 4 legs and screens, so you don't burn your eyes out. But there's no reason that the laser itself couldn't just sit on top of the material with nice felt feet.
True, but I mean,
and we don't have to limit ourselves to one pedestal.
Yeah, but I mean, then we got to deal with,
it's once you get the bottom off, it's extruded channel on the frame, right, Jim? So we could, as long as we get nuts into the extruded channel, we could bolt whatever we want to the bottom.
Correct.
Yeah. Well, I was thinking, for a riser block, we could just, have straight sheet metal coming up and then screw in some channels so we could just kind of drop the whole thing and then it would locate against channel or something like that. Just secure it. Just a thought. But well, I just don't know, if we, the less we're moving it around, I think the better off we are, Just
I don't disagree, but with respect to what?
Well, I mean, if we're, taking the bottom off and now all of a sudden, you got to lift up you got to lift it up the laser to put material on top and that type of thing that, potentially,
only big material, only if you're going to put the Workshop 88 logo on the table.
Yeah.
Which might be the first thing we do.
Yeah. Yeah. I mean, I think there's just some logistics there that I'm kind of, wondering about. Then we have, piping and all that fun stuff that, you know, well, then I was thinking, okay, if we try putting a long piece, how are we gonna feed that in? We got that right by the front door, and there's not a lot of um, swing
Not
there.
in the air duct, no.
Yeah, yeah. So I mean, there's some logistical things that I think are a little bit problematic, but nothing that can't be worked over.
Nothing that
You know.
can't be overthought.
Oh no. Oh yeah. Yeah. But I found that one plan on Thingiverse that I kind of liked that I saw, and I actually, curiously enough, that layout or device looks very, very close to the next generation full spectrum rotary fixture. I don't know if you noticed that or not, but they look very close to that. So
I liked it. I really liked what you came up with there.
yeah, well, it's not that I came up with it,
I
but
mean, what you discovered or brought to our attention.
yeah. I mean, I think it'd be easy enough to fab up, So yeah, we'll have to work on that a little bit. But yeah, sure, we'll do that for you, Andrew. Yeah, no problem.
What's your big project, Andrew, that you've Huck Finn poor Tom here into working on?
Yeah.
Well, first of all, I wasn't expecting Tom to jump on it. I never know if I could control what I can Huck Finn you all to do, I would have like my projects like selected much more carefully. But no, I last week I was showing it was a piece I had made at Workshop 88 using the vinyl cutter, and it was a pint glass that I put a piece from the periodic table of elements, and I originally wanted a whole series of them, but I only did hydrogen, and I did it. I vinyl cut the stencil, and then I used the glass etching cream to etch the glass, and it came out of the dishwasher the other day, and it knocked against the counter and it cracked. And so I had to throw out that glass. And so, I think I made that before we had the laser cutter. And it was just the sort of thing where we've never had a rotary attachment. And I mean, my comment, I'll just repeat in full disclosure is, and I shared it last week. I can dig it up again, but there's someone on eBay who is selling a rotary attachment for that they claim is compatible with the laser cutter that we have. And when we looked at it last week, and I brought it up and we looked at the design, I had never noticed before, but it was very apparent that the design was 3D printed. And based on the searching that I did this last week, I'm pretty sure that person that's selling that, they designed that piece, that attachment, and they 3D print it and they sell it as their own little, business.
Gig.
And I don't, because I can't find that specific design anywhere download. So, it's the sort of thing where as a makerspace, do we want the challenge of making our own rotary attachment and all the things that go into it?
Yes.
Or do we want to actually
No.
do we actually want to make things
Yes.
with the thing that we want? And either way we go, I think we're going to need the riser. So
Why not both?
thank you, Phil. I appreciate that. Why not both? Right. So
Yeah, I mean, eventually, that I think we definitely need some type of riser. I mean, and that makes sense because I think that adds the flexibility to the laser. That I think that would be a good draw for the space if we could actually rotary engrave stuff. Because who's not going to want that,
Well, I want to caution you there because I did use the laser on glass and on tile, and it microfractures the surface. It heats the surface in a concentrated area, and what happens is the glass actually explodes. And
I
it
think-
is it is
So-
not like using armor etch with
I
pencil.
I think Jamie has some comments on
yes,
this.
I have the solution because I'm using a 4.5 watt engraver to do tile, and I've seen like the groups I'm in, people doing glasses all over the place, basically, and just glass tile. A lot of people, not sure if I've specifically seen someone use a K40 on a glass. It's just I don't pay attention too much to what machine people are using, but
You can do it and it's going to look beautiful, but when you touch it, you'll get a million little glass slivers.
well, so what it's doing is you're covering the material in a matrix and taking the matrix off and chemically etching. You're not direct, so you're marking, you're not engraving, more specifically, is the method.
Oh, well, cool.
Which is basically like how this glass, I mean, it's not that I made this glass because I didn't, but that's how it was made.
So
It's that.
what do they put over the glass first?
So what I've been using is Rust-Oleum 2-in-1 painters matte white finish. So like Laser Mark and Theramark are the like super expensive brand name products that are probably like the communities that are doing engraving and stuff have gone through, and it's basically some spray paints work better than others. It's depending on your machine and your application, you kind of have to fiddle with it if you don't want to spend $40 a can or
If
whatever
you
it
want to
is.
mark steel, you should try. I
Mustard.
know everyone talks about mustard, but mix alcohol with rubbing alcohol.
Really?
Plaster of Paris and rubbing alcohol. That's
Okay.
a remarkably good, cheap coating.
I'll have to try that.
Yeah, it's cool. I think we have a blog post on it somewhere.
I still remember your picture of etching baking with the Workshop 88 logo.
That was my certification card. It's not hanging on the wall.
Jamie, I want to back up to that. Putting the spray paint on the glass. You're saying that the spray paint is what you laser off, and then you use the etchant stuff over it.
No.
Or-
No. So you laser your design, like you have your glass, you spray paint the glass where you want the engraving, and then you engrave it, and then you take the spray paint off with like acetone or lacquer thinner, and then you're left with the marking on your object.
Okay, and so the spray paint also handles the not getting glass shards, basically.
Well, theoretically, you're firing at a low enough power that you're not doing that.
Okay.
I'll try it.
So I know I'm 100% positive because I've seen the people doing it with their not 40 watt engravers. Theoretically, you can just turn the power of your engraver down, right? To achieve it. So I don't know what I know the cheaper K40s that I've been able to play with and seen a little bit more. Some people have like a minimum power level that they can fire at, but I think and I just generally avoid the Glowforge community, but I think if I dug into that a little bit, I could see what they're able to do, and I have a feeling it's a pretty common and achievable thing
Hey,
to
if
do.
you've got a recipe, we can iterate on the details. So, or if you
Yeah.
have ingredients, we could iterate on the recipe. That would be a good way to
And-
put it.
And there is a very active community that's very willing to help too, just on the internet. So
Cool. Thanks.
Sounds like we need a rotary. Oh, hey, so I had found this I downloaded from Thingiverse, and I was having some issues with the SVG file. I wanted to convert the SVG file into a DXF, and I actually tried using the Inkscape conversion utility, and what did I run into? I was running into some let me see, I got actually the I was getting a DXF conversion error, and then they were talking about I had to go in there, and they were saying I had to modify the SVG element attribute with width equals 100 or something on the actual error that I generated. I'm probably going to post that up on Slack. I wasn't quite sure what they were looking to do, but life could get a lot easier for this if I can get these into DXF. So like I said, it was an SVG that had, and it was erroring out on the Inkscape was erroring out when I was trying to convert it. So maybe if someone could take a look and give me an opinion on that one. I could post the links, the file, and what I researched so far. I just got stuck on it a little bit. I wasn't sure what to do. So yeah, that might help. Anyway, I'll put that up on I'll put that up on Slack. But that was kind of like slowing me down a little bit on this. Yeah.
Do you have
So
all the rest of the hardware you need?
What's that?
Do you have all the rest of the hardware you need?
I think pretty close. I mean, I have there's some 15. I got some Misumi square rod. I got like a, they had a promotion a while back that you do your first order, you get $200 free. So I had ordered up like $200 worth of this Misumi aluminum rod. So I have a big pile of that. Then they were talking about the V rollers on there, and I have some Maker Slide V grooves in inventory. I think that could be used. Stepper motor, got that. And I don't know if we want to 3D print the components or do something else with them. Cut them out out of plastic or whatever. But like I said, I'm kind of, that SVG file is messing me up right now.
I'd say whatever's fastest. We can always, we're good at iteration once we get something in place and improving it.
Yeah.
But
yeah.
I don't want to overly complicate anything.
Or if we want to go straight with that one design from Thingiverse, or if we want to because even on the SVG file, we could probably burn it out of plastic, I would think. Well, there you go. Do we want to do that and make it out of plastic? Then all of a sudden have it in the laser and get it ablated? There's a few things we got to think about on this.
3D printed or acrylic, it's gonna be in the laser. It's
yeah.
You wrap it in foil, maybe.
Well, yeah, okay. If we're going to over-engineer, if we're not going to laser cut the part, I mean, I guess another option would be, making it out of polycarbonate and then milling the parts out.
You don't want, if we hit polycarbonate with the laser, then we're releasing chlorine.
Wait, I thought that was, well, wait a second. What? Well, isn't that, it won't.
You can laser acrylic, but not polycarbonate.
But the actual beam won't go through polycarbonate. It's absorbing, right?
Yeah, but it'll melt. You can start
gotcha.
a fire.
Okay. So we don't want to.
But so we've got polycarbonate in back, and that's what I said. We should if we build a pedestal, we should build it out of polycarbonate because it's UV opaque. That's why the lid is polycarbonate. Right. And it's bulletproof and all the rest of that crap too. So but it would allow you to see what you're doing for the setup.
Oh, that gets kind of freaky though. That you're that. Well, although you got the lid out of that too. Yeah. Huh. Well, so then if we wanted to do that, well, although we probably wouldn't want to have a direct beam hitting it, is what you're
Yeah,
saying.
I mean, but no one should be aiming for it anyway. And
Yeah,
once again, you
still,
wrap it in foil or spray painted silver. I don't know what the hell. So I do have one more thing for today, a
Yeah.
little thing, but I don't want to cut you off.
No, feel free.
I had one more comment about the rotary. I just dug through Retina Engrave and pulled down all the tabs and stuff. I couldn't find any reference at all to using a rotary. So I don't know whether there's different firmware on the laser or a different firmware package to drive it that we need. 'Cause
Actually,
I
Andrew
couldn't
had
find out
addressed that.
anything
We just
mentioned it.
we just need to scale your design vertically. So you hook up the y-axis to the rotary, and then you scale your design vertically to match the diameter that you're printing at. The
Gotcha.
diameter of the driven diameter. It can be conical. If you drive the mouth of a cup, it's the mouth. And with this mount that he found, you can mount a cup like a what's the kind of glass you just broke, Andrew?
Pint glass.
Pint glass. You know that they're tapered. You can
Yeah.
mount that such that the top surface is flat, and then it'll rotate properly. So yeah,
The design is actually a clever design. I think that's
sure
one-
it is.
I mean, we don't have to. We could actually just make it. And without
I
too
was
much-
thinking of things like a lathe, spindle plate kind of stuff, or three jaw chuck or something.
Yeah, I was too.
So
and
not necessary. So,
yeah, and Andrew had got me going. I started, going through, images of that, and I kind of hit that one, and I was like, huh.
I actually think, and I could be wrong, but I actually think that in terms of things that you want to spend your time thinking about and over designing is converting from rotary to not rotary and, changing those motors, that like unplugging and reseating and whatever. If I were you guys, I'm not you guys. If I were you, that's where I would spend my energy in over engineering things.
So the biggest problem that I see is that we can't have someone do it while the motor drivers are powered. That will almost certainly destroy a constant current motor driver. So I don't know how we could interlock that. But otherwise, we got all kinds of pin connectors. And you know what? Tom's involved. So we're going to have aviation connectors on here somewhere.
And maybe
I ordered a whole bunch
Well,
from
you're
AliExpress.
What you're describing, Andrew, sounds like a math problem that should be handled in software.
Yes, exactly.
We don't have access to software.
Ugh.
The wires, though.
All right. So, Scott, you said you had one last thing for us?
Yeah, so this circuit board that I showed you earlier, I'll get back to this, but so this is the driver out of an LED light bulb. I was over at my daughter's place, and she had some light bulbs out. And I go up there, and the bulb's out, and this story's already really boring. So of course, being a maker, I just brought the light bulb home because it wasn't an incandescent bulb, and I tore it apart. And I'm thinking, well, maybe I can get this to work again. Now, I'm no Big Clive. Big shout out to Big Clive. Check him out on YouTube. He's awesome. He does all these teardowns and reverse engineers this stuff. But I did tear this apart, and I do this. So this is my test fixture where I was soldering onto it. And you could see that there are 4 yellow LEDs and these orangey ones, 5 of these orangey ones, and they're all in series. And this part looks plastic, but it's really a painted metal heat sink. So I know these will probably run hot sooner or later. I just threw the bulb and everything else away. Well, I put these on my power supply and I couldn't get anything out of them. So, which is why I started soldering these connections to them. Each individual one of the orange ones has a 30-volt drop. So they're LED arrays. And the yellow ones have a 16-volt drop. But my God, when they get to that threshold, they're bright as hell. There are LED arrays in there or inside the component. There's multiple devices. The orange ones are a little pink. The yellow ones are a little green. And all together, they, you know, when the light bulb's working properly, it's a soft, it looks like an incandescent bulb. I don't know what I'm going to use these for, but holy smokes, are they bright. But then I said, okay, 16-volt voltage drop times 4 of the yellow ones and a 30-volt voltage drop times 5 of the gold ones. This thing runs at 216 volts. The voltage drop for those. Oh, and it'll blind you at 10 milliamps. Barely registers. Like it goes from 0.00 to 0.01 on my power supply, and you can't look at it anymore. And it runs, I mean, you're touching it and it runs cool. So LEDs are just, if you grew up with light bulbs, LEDs are really cool. Now, and this, so which made, there's only one semiconductor on the driver board, and you can see, maybe you can see, thank you camera, that it's, well, you can't see. It's, it looks burnt. There's something wrong with it. So I'm not going to tear into this too deep, but it does look like a conventional capacitive diode voltage doubler on the front end, and then a bridge rectifier, and then it's doing something to deliver presumably constant current for the LEDs. But yeah, this is garbage though. And she has another bulb that's out, so I'm pretty excited to get back over there and scavenge that. So
What prevents a working bulb from blinding you?
when I said it could blind me, unlike the laser, I really was being facetious. Oh well, I can, and let me see.
You just meant super bright.
This was almost the first episode of a maker throws something away.
Almost,
Yeah.
but it didn't actually make it to the trash can. It was still on my desk. This looks like a light bulb, but it's plastic. It's actually hard plastic. They're very durable. And over the element, the diffuser just makes it look and feel like a light bulb. I mean, it throws a hell of a lot of light. So
I think what you should do with the LED array that you have is you should turn it into a flashlight that we send to Biff.
wow. Okay.
I mean, with batteries and all, you know.
You're allowed to think that.
A 250 volt to flashlight? That sounds
Well,
perfect for Biff.
Yeah.
It only needs to be 30 volt because I could put these in parallel.
You are completely missing the point.
No, I'm not. Any word from Ray? Is he doing all right? Wasn't he having something else done?
Just what I see on Slack.
All right, good. Well, anyway, that was all I really had. Oh, what do you got?
I'm building a tally system for a friend's local church, and I'm to the point where I'm actually building case and electronics and Arduinos. So hopefully I'll have something for next week or the week after.
Well, hopefully we can see that Cylon soon.
How are the digits on there? Are they?
So a tally light is the light that goes above a camera to tell you which camera is active.
Just 1, 2, and 3. Okay, yeah.
So you've got the cameras in stage order. You've got a heartbeat. You've got brightness. Beep. And you've got a test mode that does a Cylon back and forth over the LEDs, a run. And then because sometimes in the ceremony, you don't want any lights on, you can just turn the whole thing off. So
That 3D printed?
yeah, 3D printed. This was
Wow.
quite interesting and intricate because it's actually printed in 2 steps. So I've got white first and then black on the back. And so I actually managed to build the whole lettering using 3D printing.
But that lettering, at least as it's showing on the camera, really looks sharp. That can be challenging to
Yeah.
get the space to behave. That's nice.
I'm pretty proud of this. And I really do like my fuchsia.
So did you basically swap the filament somewhere, go from like black filament to white filament then, or?
So it's printed from the white up. So printed like this.
So you got a dual head?
No, Prusa Slicer actually has a feature. Now, I have multi-materials, so I could have just printed it in one go, but there's a feature in the Prusa Slicer that says at this layer, let me change filaments. So that's all I did.
Huh.
And then I've got the case, which I happen to print at the same time. And this one's pretty intricate too, because it's got a wiring hole that clamps the cable. It's got standoffs inside to keep the Arduino safe. I even put a boss on the side, so the Arduino basically slides in and locks physically. With the lid on it, it doesn't move.
Cool.
And yeah, Thingiverse even has an Arduino model. So I was even able to get the Arduino model and use it to cut all the various holes and mounting points. So it was pretty slick.
You're showing us this next week?
It's either probably the week after.
Okay.
I'm not going to be here for next week.
So just a dumb question on when you swap out the filament there. Like I know I think on my hot end I got some issues there. Do you get like a lot if you're going from like what was that, white to black? How far does it go before it goes like pure black? Because don't you go like gray for a little while then?
This I run PETG,
Yeah.
and there's basically no mixing.
Really?
Yeah, it's pretty dramatic. I let it feed through the automatic purge fires. It spits out, a tiny little squirt of plastic, and it's already flipped.
Huh.
So
Yeah, because on my hot end, when
pretty
I
lucky.
change colors, it's like there for a while.
I have had amazing luck with my Prusa. Basically, no issues that I haven't actually done to myself.
Huh. Cool.
Yep.
So you said, here's my question. You said on the test pattern, it does the siloning. Are we officially like declaring that Knight Rider as an effect is no longer culturally appropriate? Like we can't, like it's too old of a reference.
I thought the official term.
What?
I think the official term is a Larson scanner.
Larson scanner.
Oh. Where's my
for...
cultural reference?
Right. Thank you.
Larson scanner.
And I think the Larson scanner was invented for either Battlestar Galactica or Knight Rider, one of the two. I don't know.
I'll have to look it up.
Larson was the name of the person that came up with it, I guess.
I guess
so you're saying
can
that's
geek out.
the actual technical term for it.
That's the name I've heard.
Huh.
Of course, Phil told me that.
Christine, thank you for understanding where I'm coming from. That's all that matters to me. These people with their actual like information, and who has time for that?
Well, turns out, yeah, he worked for Battlestar Galactica and Knight Rider.
And Battlestar Galactica is older, isn't it?
It's both older and newer.
Exactly, it's older and newer.
Did anyone get that? Should be the Gort light.
Gort.
From The Day the Earth Stood Still.
Oh.
No.
All right.
Good movie.
On that note.
Yeah.
Barada Nikto.
Okay.
Nice. Who said that?
Nice.
Well done.
It's the only foreign language I've been able to pick up.
Very cool. All right. Well, thank you all for another great Tuesday night, and we'll get this posted on YouTube. And do I need to say anything else? What's our out? Scott, you got us out, or are we good?
Like, subscribe, ring that bell, share cocktail recipes.
Thank you. Yes. Follow us on Facebook, Twitter, and all the socials, right?
And you can join us anywhere in the world on Patreon.
That's right.
Hey,
Okay.
all right.
Thanks.